Hello, mathematicians! This is the notes video for Chapter 3, Lesson 6, Part 1. The learning target today is, I can write linear equations in point-slope form. So here's a recap of kind of what we've done so far with linear equations. We've learned how to write linear equations in slope-intercept form, y equals mx plus b, and in standard form, ax plus by equals c. Point-slope form is written as y minus y1 equals m times x minus x1. We have not covered slope form, or point-slope form yet, but this is kind of where we're heading. And the cool thing about it is that m means slope in this equation, the point slope, and in the slope-intercept form. And then the x1, y1 is a coordinate that's given. So those are going to be actual values of numbers. All right, let's keep moving on with our lesson. Write linear equations, lesson 6, real world link. Zoo. The cost for 1, 2, 3, and 4 people to go to the zoo is shown in the table. So x is the number of people and y is the total cost. So if there's one person, it costs $13. For 2 people, it's $22. For 3 people, it's $31. And for 4 people, it's $40. Is the relationship linear? Explain. Okay, immediately I see that the relationship is not proportional, but that doesn't mean it's not linear. We have to find the constant rate of change, or the change in y over change in x. So, from 13 to 22, it's a change of positive 9. So I'm going to write that down. 9. From 22 to 31, it's a change of positive 9. And from 31 to 40, it's a change of positive 9. From 1 to 2, it's positive 1. From 2 to 3, it's 1. And from 3 to 4, it's also positive 1. So, the change in y is 9 over the change in x of 1. So the relationship is linear, yes, because it has a constant rate of change. What is the slope of the related graph? It's 9 over 1. That's our constant rate of change. That's our slope, which is just 9. Now we have to choose an ordered pair. We can choose any of these, 1 and 13, 2 and 22, 3 and 31, or 4 and 40. I kind of like 4 and 40. And I have to write it as x, y in that order. So my x value goes here and my y value goes there. So I'm going to switch colors. 4 goes here and 40 goes under the y here. Then we need to substitute the values into the equation below. So our 4 would be where our x goes. So 4 goes here. Our 40 goes where our y would go, and our slope goes here, m. Now we have to solve for b. I know that 9 times 4 is 36, and so I have to get b by itself, so I have to subtract 36 from both sides. 40 minus 36 is 4, so b is 4. So that's our y-intercept is 4. Write an equation of a line in slope-intercept form. Slope-intercept form is y equals mx plus b. And I know my slope, which is 9. And I know my y-intercept, which is 4. So I just have to substitute in those values. Y equals 9x plus 4. Now I can graph it. My y-intercept is at 4. And if I start graphing the ordered pairs, I see 4 and 40 is one of the ordered pairs. And I just need to connect a line. 1 and 13, 2 and 22, 3 and 31, somewhere right there. Okay, now I'm going to draw a line. So I graphed the data and drew a line to connect the points. point-slope form of a linear equation. I know I already talked a little bit about point-slope form, but you can write an equation of a line in slope-intercept form when you know the slope and the y-intercept. You can write an equation of a line in point-slope form when you are given the slope and the coordinates of a point on the line that is not the y-intercept. So this is where point-slope form is useful, because you can write an equation of a line in point-slope form when you are given the slope and the coordinates of a point of the line that are not on the y-intercept. So that's when it's useful. And you can write it in this format. So let's move on to our examples so that it makes a little bit more sense. Example 1 says, write an equation in point-slope form for the line that passes through -2, 3 with a slope of 4. So I'm going to use this format, and I'm going to identify my y1 and my y2. So x, y are how I write coordinates, and then my x1 and y1 are in those colors. So my x1 is -2 and my y1 is +3. So that's my x1 and y1. And then my slope is 4, so m equals 4. So then I can make a template, y minus y1 equals m times x minus x1. And so I can just substitute in my numbers for those variables. First, I'm going to substitute in y1, which is 3, right here. Then I'm going to substitute in my m, which is 4. And then I'll substitute in x1, which is -2. So I wrote the equation in a point-slope form, and now I have to simplify it. So it'll be y minus 3 equals 4 times the sum of x plus 2. And we get plus because we had to chop the negatives. So when I chop negatives, that's actually when I subtract a negative, it's actually like adding a positive. So that's how we got x plus 2 there. All right, so now I'm going to box it in, and that's the point-slope form for this equation. Example 2 says, write an equation in point-slope form for the line that passes through -5, 2 with a slope of 1/3. So I'm doing the same thing that I did in my first example, and I've got my template up here, and so I can make another template down below. Y minus y1 equals m times x minus x1. And so I've got the little spaces that I'll put those numbers in using this template. It says, so since we're writing an equation in point-slope form, I need to identify my x1 and my y1. And since I know that x and y are written in that order when I write coordinates, I know that -5 is my x1 and 2 is my y1. So that's my coordinates for this problem. And then my slope is 1/3, so m equals 1/3. Now I'm going to substitute those values into the equation. Y minus 2, and then my slope is 1/3, and then x minus x1, and x1 is -5, so it's x minus a -5, don't forget your negative, and it's chop, so it's actually x plus 5, so plus a positive instead of minus a negative. And now I'm going to simplify. Y minus 2 equals 1/3 x plus 5, or times x plus 5. Then I'll box it in, and that's my answer. So you have a couple problems like this in your book, and I want you to practice.